Welcome to this tutorial video. Today we'll be looking at compounding interest, and in particular the compounding interest equation. Now this is part one of a two-part video sequence. This is the equation we use to calculate the value of an investment following compound interest, and we'll come back to that shortly. First thing to recall is that a compounding interest equation really is based upon a geometric recurrence rule. Here we have a value. We multiply it by a ratio, we can work out the next value. This is exactly how investing compound interest works. That ratio R, when we're talking about compounding interest, is described as the growth or compounding factor. It's equal to 1 plus the interest rate over 100. So let's go straight into an example. If I invest $1,000 at 5% per annum, compounded annually, which means at the end of every year, the interest will be added to the capital and my investment will grow. I want to examine the first 5 years of investment. So here's our recurrence relation. The next term or value will be equal to the previous multiplied by our growth rate or growth factor. And our initial value was $1,000. Now again, our rate or our factor here will be 1 plus the interest rate of 5 over 100. So as a decimal it comes out to 1.05. And that's important for our calculations that follow. So at the end of the first year, we take our initial investment of $1,000, what we commonly refer to as our principal, and we multiply that by a factor or a rate of 1.05. So at the end of the first year, our investment is worth $1,050. Compared to the $1,000 we started with, it has gained $50 interest. At the end of the second year, we take that $1,050 and we again multiply it by our growth rate of 1.05. That gives us a value at the end of our second year of $1,102.50. Again, from our initial investment, we've gained $102.50 interest. Now this can be calculated in one simple step. If we wanted to start with our initial value and multiply it by 1.05, that's where we get our 1050 from. Then again we're multiplying it by 105 again. So we could have written this as starting with our initial value V0 of $1,000. We've multiplied it by the growth rate of 1.05 twice, or rather the growth rate of 1.05 squared, to predict the value at the end of the second year, which is exactly the same as our initial recurrence sequence method. End of our third year, we take our investment after 2 years and we multiply it by our growth rate of 1.05, and that gives us the value at the end of the third year of $1,157.63. Again, we could have alternatively taken our initial value of 1,000 and multiplied it by the growth rate of 1.05 3 times, and that will also give us the same return at the end of 3 years. 4 years is exactly the same. We take our value of our investment at the end of the third year and we multiply it once again by our growth rate of 1.05. That gives us a value. Our investment will be worth $1,215.51 at the end of our fourth year. Again, alternatively, we could have started with our 1,000 and multiplied it by the growth rate to the power of 4 years to work out its value at the end of the fourth year. Finally, let's look at the fifth year. We take our value from the fourth year, $1,215.51, and we multiply it by our growth rate once again of 1.05. That gives us a final value of $1,276.28. So compared to our original investment of $1,000, we've gained $276.28 of compounding interest. Once again, we could have started with our initial value of $1,000 and multiplied it by our growth rate of 1.05 on 5 separate occasions, or multiplied it by 1.05 to the power of 5. It also predicts the value of our investment after 5 years at the end of the fifth year. Here's a shortcut for our equation, which tells us we can predict the value of our investment at any number of years down the track if we know our initial value or our principal, the interest rate per annum, and the number of years it's being invested in. Our final example, if I take our 1,000 that was being invested at 5% per annum, compounding annually, what will its value be after 20 years? We sub in our initial value of $1,000, our rate annually, compounding annually of 5%, and 20 years. So it's 1,000 multiplied by 1.05, the growth rate to the power of 20. And that gives us a return of $2,653.30, which, as you can see, is an interest above the 1,000 of $1,653.30. I hope this helps explain a little bit about the compounding interest equation. Stay tuned for video number 2 on this topic, which will look at time periods other than annual, such as compounding monthly, compounding weekly, or even compounding daily. Thanks again for watching this video.